Welcome to SolidCAM Professor. I'm Sydney, your SolidCAM Professor, with one of many videos available to you 24 hours a day, 7 days a week. In this recording, I'd like to demonstrate several of our options that we have inside high-speed machining, also known as HSS, on this part as shown on our screen. We're first going to start off by machining these corners over here, these radiuses, as well as this side and these two sides as well. So if we go into our first of our HSS operations, we'll be using the option of engraving using projection as shown over here. Our geometry in this particular case, if we show the faces, are going to be these faces over here, the actual radius. And the projection curve is going to be this curve along the bottom of that radius. So the tool will actually engrave itself on that line and according to that particular radius. Now, the tool that we'll be using will be a 10 millimeter ball end mill, which is the exact radius that we have on the part itself. If we go down now to our roughing and more, we'll take a quick look at our depth cut. Our depth cut, we've done the following. We want to have several step downs, so we'll have a number of 3 passes, and each one of them is spaced at 1 millimeter apart. Let's take a look at our simulation, and you'll see that the end mill will go down, work exactly on that particular curve as shown over there, and this will be done in 3 steps. And if we take a close look at that, you'll see we actually have those steps that we talked about, plus the finish cut. Now, with the next 2 operations that we've done, we also do the same on this side, as well as these 2 operations working on the flip side, as we can see on the part over here. Now, in the next 2 operations, I'd like to do the following. I'd like to work on this surface over here, as well as the ones on the flip side as shown over here. To do that, I use the option of morphed between 2 curves. What that will do is actually give me an even step on the surface between the actual curves. So if we take a look at the operation, you'll see the following. We're using morph between 2 boundary curves, and our surfaces that we'll be working on will be the ones as shown over here on this flip side. And we have our start edge curve and our end edge curve. The start edge curve will be this edge over there, and our end edge curve will be the one at the bottom, and it will spread in evenly spaced steps between those 2 edges. The end mill again will be the 10 millimeter ball end mill, and we've also done one more thing. We've done what we call a gouge check to make sure that it does not gouge into any of the surrounding areas. If we take a look at the gouge surfaces that we've chosen, you can see that it's all the surfaces around those areas, making sure it does not touch any of those areas itself. Let's take a quick look at the simulation, and you'll see that the tool works exactly evenly on that surface. Taking a better look using Solid Verify, you'll also see that the tool will work only on that surface and not gouging any of the part itself. Now, the same was done for our next operation, working on the flip side on that surface over there. Now, for our next operation, I'd like to work on this floor over here. So we've done that by using the option of parallel to curve. By parallel to curve, if we take a look at the geometry, the drive surface will be that floor over here, and the curve that I've chosen is the one going around that surface. So in essence, since we'll be working parallel to those curves, it'll be almost like working in a pocket form on that floor. If we take a quick look at the simulation, you can see that it is working exactly on those areas over there, just like it'd be working on a pocket. Now for our next operation, I'd like to work on these areas over here, this particular fillet, as well as these surfaces over here. So for that, we've again used the option of morph between boundary curves. The drive surface in this particular case will be these surfaces as shown over here, and the edge curve, the start will be the one going around the top of that bound of those surfaces, and the end edge will be the one exactly on the bottom. So you'll get exactly an evenly spaced toolpath between those curves. The end mill I'll be using this time will be a 6mm ball end mill. And if we take a look now at the simulation, you'll see that it's working exactly along those curves on that surface, working its way and also changing its shape to get the exact shape needed to give you a nice smooth finish on those surfaces. For more videos on SolidCAM Professor, please go to our website www.solidcam.com and look for our Professor tab. Take care and have a nice day.